In this video, we'll have a look at how logical operations can be used to select elements from an array satisfying given criteria. I'll create a random array of integers from 0 to 20 to use for the demonstration. And I'll define the array so that it has 10 rows and 5 columns. I can use the less than operator to find which values in the array are less than 15. The result is a logical array. So this value here, for example, indicates that the value in the first row, first column was not less than 15. This one here indicates that the value in the first row, second column was less than 15. This array can now be used for logical indexing to get the values from x that are less than 15. I type x of x less than 15 and I'll get the results. I can count the number of values that were less than 15 by using this together with the length command. I also could have summed up the logical values to get the same result. What will happen here is, because we have a logical array, when we try to invoke the sum command, it will be first converted to a numerical array of 1s and 0s, and all those 1s will be added up. Well, not quite, because the sum command sums down the columns of an array, so we'll have to sum up this result again to get the total we were after. If we want to find what positions the values in the array were, we can use the find function. If I want the values that are less than or equal to 15 in the array, I can use this syntax. If I want the values that are exactly equal to 15, I can use this double equals sign. The reason it needs to be a double equals sign is because the single equals is reserved for the assignment operator. If I type this, I would just make x equal to 15, and that would overwrite my definition for x. So what we'll do now is find the locations of any values in array x which are equal to 15. And there are just two values, which are the 25th value and the 30th value. So let's just check that. X of 25, yes, that's equal to 15. And x of 30, yes, that's equal to 15 as well. We can also compare two arrays of the same size using this method to see if the elements are the same. For example, let me make a new array y, which is exactly the same as x, and then I'll just change one of the elements in array y so it's not quite the same. Then we can compare the two arrays and we can see that there's one standout element which is different. One place where this type of operation is useful is when looking at the difference between two images, because images are represented in computer memory by arrays of pixel values which are numerical. If I want to compare two arrays to see if they're identically equal, then I need to use the isEqual function. In this case, the two arrays are not equal because I changed one of the elements. Another useful logical operator is the not operator, which negates the true or false values. So if I type not true, I get false. If I type not false, I of course get true. The operator can also be used on whole arrays, so for example, not x equal to 15 gives the values in array x which are not equal to 15. Another way of writing this is using the tilde wherever I would see not, like this, or using the not equal operator. Finally, let's look at ways of combining logical results using and or. For example, if we want the values in the array which are between 5 and 15, we can say and x greater than 5, x less than 15. This will not include the two endpoints, so anything that's strictly bigger than 5 and strictly less than 15. Apparently the function is lowercase, like all MATLAB functions. Another way of writing this would be to say x bigger than 5 and use the ampersand, x less than 15. The AND operator requires that both conditions are true. The result not and x bigger than 5, x less than 15 will give any values that are outside the specified range. I can also do this with the OR operator. Let's select here any values which are less than or equal to 5 or bigger than or equal to 15. Another way of writing this is x less than or equal to 5 and use this symbol here, which on my keyboard I get by typing shift together with the key that's right next to the shift. So this is another way of writing the OR condition. The OR operator allows for the possibility that one of the conditions is true or that both of the conditions is true. This is distinct from the XOR function, which is called the exclusive OR. The exclusive OR function requires that exactly one of the conditions is true. In this case, there would be no difference between using OR and XOR, because it's impossible that a number can be both less than 5 and bigger than 15. But if, for example, I did XOR x less than or equal to 15, x bigger than or equal to 15, it would give me all numbers except 15, because the number 15 satisfies both conditions. So this expression is equivalent to x not equal to 15.